Hello, this is Mehmet on Calis. My student ID is 800 357 651. Today I'll be talking to you about my Kiva project for my machine learning course. This semester we have learned supervised machine learning models. These models need a tag target label for each observation, which consists of many features. Supervised machine learning models split data into two parts as training and test data. Models use these training data to create a model and test data to the performance of model created. Critical point here is to have each data to have a correct label. When I examined the supplied Kiva datasets, I only see multidimensional poverty index data for such a target label. This label is not available in loans dataset. There is country and region within country data in loans dataset that could be used to obtain MPI data. Kiva also supplied an MPI by regions dataset, but the MPI data supplied there for almost all regions did not get any Kiva loan. It was obvious that the loan supplied to a region of a country has to be supplied by external datasets. I examined poverty and equity database supplied by World Bank, but it only contains country-level poverty information. If I use this dataset, then my model will look up country data and always correctly predict country-level poverty information, which is not a machine learning model at all. I checked several other resources, but I could not locate poverty data for Kiva loan regions. It was obvious that it would require many resources and a long time to obtain poverty data for Kiva loan regions, since most of them don't exist. Therefore, this task was impossible to accomplish within this assignment period. Our instructor indicated that the purpose of this assignment is to present our knowledge of materials in this course. So, after examining supplied Kiva datasets and external poverty datasets, I have decided to create models to predict the sector of a loan, given some relevant loan features. This will clearly present my knowledge in this course about how to create, assess, and use machine learning models. In the second chapter, I examined the contents of 4 datasets that were supplied by Kiva and 1 external dataset that was supplied by the World Bank. After examining all these datasets, I found out that all my model data is available on Kiva Loans dataset. I eliminated the unnecessary datasets and columns. At the end, I decided to use the following columns as my target label and feature columns. The following meaningful columns are the sector column, loan amount column, country column, term in months column, lender count column, borrower gender column, repayment interval column. You can see the cleanup process of the unnecessary datasets here. When we look at the data in detail, we can see that 3 sectors, agriculture, food and retail, get nearly 66% of all loans, and 2 countries, Philippines and Kenya, are the 2 top countries that obtained these loans. My sector data has 15 classes and I have 6 features. I have plotted sector classes for each combination of my 2 features. From all these scatter plots, I have observed that my data is a highly nonlinear data. I also have outliers, 1 loan of 100,000 and 1 lender count of close to 3,000. I will keep this outlier in my data and decide whether to remove after trying several models. You can see the scatter plots here. In chapter 4, I prepared the data for machine learning algorithms. Since my target label sector has 15 different classes, my model will use classification machine learning models. I have to convert my non-numeric features to numeric values by using label encoder and standardize them using standard scaler. In chapter 5, I will explore different models and shortlist the best. The first machine learning model I investigated is decision tree classifier with a specified maximum depth. When we look at the values obtained here, it has a precision of 38%, recall of 39%, and an F1 score of 36%. The second one is decision tree classifier with no depth limit. And on this one, the precision increases to 42%, recall is 43%, F1 score is 42%. The third one is random forest tree classifier with limited depth. And on this one, the precision is 38, recall is 38, and F1 is 33%. The fourth one is random forest classifier with no depth limit and increased estimators. And here we got the precision to be 43%, recall is 44%, and F1 score is 43%. Begin classifier model, the precision is 26%, recall is 35%, and F1 score is 29%. With AutoBoost classifier with limited depth, the precision is 41%, recall is 43%, and F1 score is 40%. In terms of my conclusion, you can see my solutions at the 7th chapter. Basically, all my models resulted in poor predictions. The best prediction was done by random forest model with unlimited depth parameter. This model's prediction of 4 sector classes were producing acceptable results, but the prediction of other classes were very weak. Therefore, my recommendation is not to use these models and invest more resource and time to introduce some new features into the data. For example, Kiva site indicates that you can see information about borrowers, but this personal information about borrowers were not available in the supplied loan datasets. If Kiva makes this borrower personal data public, our models could make much more accurate predictions.